Hello, let's start the presentation. Uh, this homework, this assignment, I will deal with the denoising process. I will do the denoising for the our lecture recording. For example, during your coursework, you sometimes record the lectures for later study. However, when you listen to the recordings at home, you often find that excessive noise normally makes reviewing the material irritating. To solve this issue, you decided to develop the program that can filter out this external noise. So first question is to filter out the noise, which approach is more appropriate to use among the one-dimensional signal processing and two-dimensional signal processing? And then compare the specific characteristics of the data in each domain, and after that provide the valid reasoning for your preferred choice. And second, design a noise reduction pipeline for both the 1D and the two-dimensional approaches. After that, write a program to run them using cFulfur and discuss the result you get from the execution. And
We learned this one
this
can
is
be very
the
important
audio I will deal with
concept
today. This is
that
kind of
requires
just a lecture
ongoing
recording from the
study.
KAIST and the introduction of the lecture. So as you hear, the raw recording data contains various external noise, including the just the background hum noise from the AC and the Apple Pencil tapping noise, like when person writing down, and sneezing from the another person. So let's just start. Out of the first problem, I will deal with compare the specific characteristics of the data in each domain, one-dimensional and two-dimensional. And and on one-dimensional noise processing, main disadvantage of the one-dimensional noise processing is I think loss of the timing. Because FFT algorithm loses the exact timing of when they occurs, or from that, all type of sounds are mixed together on a single time axis. So as a result, not only we can use restricted tool like low pass filtering, high pass filtering, notch filtering, but also filtering itself removes the noise across the entire time domain, which normally cause the damage the original signal. However, on the two-dimensional notch processing, thanks to the short-time Fourier transform, we can divide the signal into short windows and apply the FFT to each segment. As a result, we can pinpoint exactly which frequencies are dominant at each specific time. That means we can selectively eliminate the specific noises without damaging the overall speech signal. The image on the right shows the spectrogram of the lecture recording you heard earlier, just before. As I mentioned before, thanks to the short-time Fourier transform, we are now be able to analyze the data in two-dimensional. I mean, first x-axis is the time and y-axis is the frequency. This allows us to classify different type of the noise based on their geometric pattern. For example, look at the blue vertical line. Since it spans across the all frequency at specific moment, it presents an irregular impulse. We can predict this is sound like someone next to you tapping the Apple Pencil while taking notes. The orange line and also the orange line occurs in the 1000 from the 1000 hertz to 5000 hertz frequency range. We can infer that this is the actual lecture sound consisting of an adult male's voice. As for the light green line, it appears randomly from time to time, so we can assume it's general background noise. Because we can pinpoint each type of the noise at specific time, and frequency like this, I concluded that two-dimensional signal processing is a much more convenient and effective approaching for removing noise and securing a clean lecture recording. So I will start the design. I will start to design the filter. At first, I will go for a 2D filter. I will use a conditional medium filter for the vertical blue noise. It is because a normal medium filter changes all value to the median without any condition, which ruins not only the impulse noise but also normal voice energy. But with the conditional medium filter, we catches a sound when a specific beat suddenly spikes above the threshold. n- Noise like Apple Pencil writing and sneezing from another person, and some kind of impulse noise that has a spike with abrupt amplitude increasing can be decreased. And second, I did a spectral subtracted to suppress the green color background noise. And lastly, I and background to eliminate the green color background noise. And lastly, I did not use the notch filter because in here case the horizontal noise exists at the several hundred hertz, which directly overlaps with the actual voice frequency. I mean real data we need. Using the just notch filter would actually make the noise quality much more worse than before. So I didn't use that. As a result, I can see we cannot uh, as you can see this small graph, we cannot eliminate the low frequency noise, because we cannot eliminate the low frequency noise on two-dimensional processing. I can just filter out the noise with the low pass filtering, and it looks much more clear than before. So I will do that. This is the program from the C++, and first I will do the kind of uh, proper window size and the overlaps. I did this with the optimization. And to do the two-dimensional processing, I will apply the median filter with the threshold, and I will not use the horizontal noise filter. We call that notch filter, and then I will use the subtraction filter. And lastly, I will do kind of compensate our amplitude. And this is the result of the two-dimensional process. And after that, I will use the one-dimensional. One-dimensional is just using a low-pass filtering, and doing the low-pass filtering much more harshly, I think. Uh, I we can get only real data with the low frequency noise. Before, we only can get a data with the low frequency noise with the high frequency noise. And back to the presentation material. Uh, these two are the result of just before process, and as you can hear,
We learned this one
it is
as
much
a
more
very
blurry.
important concept.
And
We learned this one
this
as
is
a
much more
very
clear
important
than just before.
concept.
So from that, we can know initially. it was assumed that two-dimensional processing would allow for precise isolation of noise by decoupling the time and frequency domains. However, when low-frequency noise is completely intertwined with the target data, it became evident that even with the two-dimensional processing, separating the noise and filtering it out using conventional legacy method remains a challenging task. In such a situation, I think we found that simply applying a low-pass filtering or basic one-dimensional processing method actually yield a significantly clearer processed audio recording. Based on this finding, a more reasonable approaching would be to first reduce unnecessary noise to increase the SNR, and then design an advanced filter using a machine learning. In conclusion, while two-dimensional processing is advantageous for identifying the noise with the geometric feature, it is computationally expensive and is not always the optimal solution. Yeah, thank you for listening, and this is all of my presentation. Thank you.